Hi, you guys, it's Miss Johnson, and we're going to talk about hybridization theory. And I said I was going to do this for a long time, so I'm sorry I put it off. Oh, yay, hybridization theory. Okay. So, just like red and blue make purple, like that's the hybrid of like when you mix them together. That's kind of what that's exactly what hybridization theory is saying. It's like we have atoms on the periodic table that have different energy levels. And I'm going to use carbon and hydrogen to explain this, right? Carbon is in energy level 2, and hydrogen is in energy level 1. And yet they seem to make pretty stable bonds. But even carbon has electrons that are in different energy levels. So it's like, if some are bigger than others, how can they be so stable, right? Well, what's going to happen is that carbon is going to hybridize within itself. It has one S shape and three P shaped orbitals, and they're going to get together and they're going to reform a new hybrid shape so that those four little hydrogen electrons can share those orbitals equally. And if you remember, the S shape has a circular spherical shape. The P orbitals are the dumbbells, and their baby is that SP weird figure 8. So if we didn't do this, it would be like driving in a car that has three wheels that are all the same size, but one wheel that's smaller than the others. Like the three P's are all the same size, but the S is a little bit smaller. And when you get a flat tire, you can feel that it's real wobbly. So we don't want to have that. Wobbly would be more like unstable. So in order for us to have a smoother ride, for carbon to have bonds that would all be the same size and the same energy level, it's going to hybridize within itself. So it's going to have one S-shaped orbital combined with three P-shaped orbitals to make an sp3. And the trick that we need to remember is that sp3 is going to be found in molecules that have 4 domains, sp2 is 3 domains, and sp is just 2 domains. And right down here I drew our examples of methane and ethane. And you can see ethane has 3 domains for each carbon. So you can see that carbon has those 4 weird sp3 dumbbell shaped, and they're all the same. And that's because they already have hybridized. And that way, hydrogen and carbon can make that nice equal bond. And it doesn't have to be a bumpy ride, so that they don't have to be different shapes, okay? So the different types of bonds that we find in molecules are sigma and pi bonds. Sigma bonds are found they're found in carbon to carbon bonds, right? But pi bonds are going to be that double bond that we would also see between carbons. So, like I said, once again, sigma bonds are always carbon to carbon bonds. But that other one, the pi bond, is actually hovering above and below. It actually is resonating above that sigma bond. And its name is just pi bond. That's what we call it. Okay? And I know that there's only 2 electrons in that other double bond, but I just drew it as like a little resonating circle. So just know that it's only supposed to be 2 there, but they're moving all around. Whee! So in a triple bond, we only will have 1 sigma bond between the 2 carbons, and the other 2 will be pi. And it doesn't matter how you label them. Like down here in this Lewis structure that I drew, you have, 2 pi bonds and a sigma bond. It doesn't matter which one is which, so long as that you label them 2 are pi and 1 is sigma. So that's kind of the big idea about hybridization theory and what kind of bonds we see. All right, here's some study tips, you guys. You need to be looking at your flashcards and studying every single day. Watch some TED Talks about memory retention. I did that. That was great. Eat your veggies. Good for everyone. Go to sleep. Sleep a lot. And then if you get stressed out, you need to be talking about your stress to your friends and family, and you need to be helping yourself relieve yourself of that stress. So you can exercise, you can draw, you can paint, listen to music, whatever you want to do that's healthy. All right, you guys, have a good night and study for your test, and I will see you later. Have a good night.